When it comes to finding domain and range of exponential function, again, exponential function is when x is the exponent. Now there's another one, the exponential function, or also known as e function. So we typically use that e function. That's another function that's going to be used later on. It's different when it's come to exponential function, the wording. So when it says exponential function, x is the exponent. So in the first video with the graphs, you would see that the graph, here's my x and y axis. You see that the exponential graph is like this. Now again, I'm illustrating at this point it's going near the x-axis but not going to cross it, not going to touch it. So just like a horizontal asymptote. So, and then the one that was in Desmo didn't give you the arrows, but here it does have arrows. So meaning that it's continuously going upward and right, and then over here it's continuously going downward towards the left, but not going past the x-axis. So, for domain of this first example, in our first example, f of x equals 4 to the power of x. So our domain would be parenthesis. Now if it's continuously going to the left, negative infinity. If it's continuously going to the right, positive infinity. Now again, domain is left and right. If I'm doing range, then the bottom of this graph, it's going close to the x-axis, so that means y equals 0. So I'm going to use parentheses 0 because the graph will never touch the x-axis nor cross it, so I'm using parentheses. That's the bottom. Now the top is going upward continuously, so I'm going to use positive infinity. So that's our domain range. Now, in our second example, g of x equals 7 to the power of x minus 2 plus 3. Now if we review with transformation, it went to the right 2 units because minus 2 is with the x, and then here is after the x, so plus 3. That means the function went up, shift up 3 units, but it still has the same parts of this graph. So for our domain, it's going to be continuous on the left, so negative infinity. Same thing, it's going to be continuous on the right side, so positive infinity. So that's our domain. Now for our range, since it's shifted up 3 units, so right here, for the first example, it didn't cross the x-axis, so it won't go past y equals 0. So it's the same thing as if I put 0. Here, there's a plus 3. What I'm going to do is put 3, parenthesis, that's the bottom of the graph, and then the top graph is going to go continuously upward, so positive infinity. That's our domain range for our second example. Alright, in our third example, we have h of x equals 2 to the power of x plus 9, and then plus 8. So again, if we were just reviewing with transformation, this function, x plus 9, it means shifted to the left 9 units. And then the plus 8 means up 8 units. So, let's talk about the domain. So again, it's positive base. So pretty much the graph is going to be just like as the one before, regardless where it moves left or right, up or down. So, if I were to do domain, the left side of the graph is continuously going to the left. So, it's going to be negative infinity. Now, over here, again, it's going upward, but it's a slant upward, so that means it's going up and to the right. So again, the reason it's going up and to the right is it's slanted. So, for domain, I'm going to focus on the right side. If it's continuously going to the right side, it's going towards positive infinity. And here's our domain. Now for our range, again, usually the typical graph doesn't cross the x-axis when there is no increase. So here we do have an increase, plus 8. So that's going to be our bottom of our graph. So I'm going to put 8. That's our bottom. And of course, if there was no number given, it won't cross the x-axis. So it used parentheses. Same thing with this one. If it's plus 8, it's going to go towards near where y equals 8 is, but it will never go past 8. So I'm going to use parentheses. So it doesn't go past or go on 8, so parentheses. And then the top part of the graph is continuing to go upward, so it's positive infinity. Now, example 4. K of x equals 3 to the power of x plus 4 and then minus 5. So again, it's pretty much the same as this graph. So our domain is the left side continues to go into the left, so negative infinity, and then the right side is slanted, so it's going up and to the right, so it's also continuously going to the right, so positive infinity. Now our range, again, minus 5, it means it's shifted down 5 units, so the bottom of the graph is near y equals negative 5. So it's going to be negative 5, that's the bottom of our graph. Now, it won't touch negative 5 or go past it, so I'm using parentheses. And then the top graph is going upward to continuously, so it's going towards positive infinity. So here is our domain and range for example 4. Now if you're confused on why we're using these values, plus 8 and minus 5 in our range, you have to go back to the first video about how the function ties in with the graphs and how the exponential function graphs look like. Alright, in example 5, we have m of x equals negative 6, and that's our base. So our base is negative 6 to the power of x plus 3 plus 7. Now, if we review a transformation, when our base is negative, the graph reflects over the x-axis. So basically flips. So our graph would be this form. So if we were to focus on domain, first is the left side of the graph. Now it's slanted, so it's going mostly towards left, but also increasing. So if it's going continuously to the left, it's going towards negative infinity. Now on the right side, it's going downward, but it's also going towards the right because it's a slant. So it's going down and towards the right. But I'm just mostly going to focus on the right. So since the right side is continuously, then it's going to go towards positive infinity. And that's our domain. Now, here's the thing we have to worry about range. When our base is negative, that means the graph reflected over the x-axis or flip. So that means our range is going to be different than the previous 4 examples. So we're going to focus on the bottom of the graph first. Just like before in domain range, we always focus on the bottom. So as you can see, it's going downwards. If it's continuously going downwards, it's going to start at negative infinity. Now, the top part, again, is just like the other graphs where it does not crosses the horizontal axis that it has. So for example, if it was like plus 3, it won't go past y equals 3. So here, our example, since the graph, our base is negative, the graph reflects. So here, y equals 7. It won't go past 7, but it goes towards near it. So it's going to go towards near it. So the top of the graph is going to be at 7, but parentheses. It won't touch it, it will go near it, nor it won't go past it. So again, it won't touch it at 7, it won't go past 7, but it will go near it. So that's why we use parentheses. So in example 6, it's a similar problem. So n of x equals our base negative 9 to the power of x minus 4 and then minus 11. So again, just like example 5, our base is negative. So it's going to be a similar graph to this. It's going to reflect over the x-axis or flip over. But it's just going to be similar to this graph. So if we were just focusing on domain, we're just going to focus on the left side, and you can see that it's going continuously to left. So our left side is negative infinity. And then if we just focus on the right side, slanted, so it's down and to the right. So focus on the right side is continuously going to the right, so it's going to go towards positive infinity. So that's our domain. Now our range is going to be the same process as example 5. Because since our base is negative, it's going to reflect over or flip over. So the bottom of the graph is going downwards continuously, so it's going to start at negative infinity. Always start with the bottom. Then the top graph is always going to be based on what number we have here. So just like right here, plus 7, it won't go past y equals 7. It's just going to go near it, but again, it won't go past nor touch it, go near it. So here, it's minus 11. So it's going to go near it, but not touch it, not cross it, so near it. So parenthesis on negative 11. And then that is our domain and range.